Here's the definition of the least common denominator and the procedure for finding the least common denominator of two or more rational expressions. So here's the definition. The least common denominator, which is abbreviated commonly as LCD, of two or more rational expressions is the least common multiple, which is also abbreviated LCM, of the denominators. So when asked to find the least common denominator, we're looking for the least common multiple of the denominators. And just a note, a common denominator is required for adding or subtracting rational expressions. Anytime we need to add or subtract fractions, the first thing we need to do is get the common denominator. Here's how to accomplish that. The steps for determining the least common denominator of two or more rational expressions, there's two steps. First of all, we're going to factor all denominators completely, if necessary. And then the second thing is, the least common denominator is the product of prime denominator factors, with each factor raised to the highest exponent it has in any denominator. Here's an example. Find the least common denominator of these two rational expressions. 5x over x squared plus 8x plus 15 and 2 over x squared plus 6x plus 9. So first thing we need to do is to factor all denominators completely if it looks like they can be factored. And it appears like they might be able to be factored because they're both trinomials. So let's give it a shot. We've got 5x over. I'm attempting to factor the first denominator now. Thinking what times what would be x squared, and that would be x times x. And then what times what is 15. That adds up to 8, and that would be 3 and 5. If we make both signs positive, it will work out properly. We'll get 5x plus 3x, which is 8x. For the second fraction here, let's try to factor the denominator. We've got 2 over, let's see, what times what would be x squared? X times x, and what times what is 9. That adds up to 6, and that would be 3 and 3. And if we make both signs positive, it'll work out properly. So we've got 5x over x plus 3 times x plus 5, and we're comparing that fraction to this other one, 2 over x plus 3 times x plus 3. Notice we have x plus 3 twice here in the second denominator, so this second fraction could be expressed as 2 over x plus 3 squared. The first fraction can't be simplified at all, so here we have 5x over x plus 3 times x plus 5. Okay, so comparing the two denominators, the procedure for finding the least common denominator is you take the product, which means you multiply all of the prime denominator factors using the highest exponent that it occurs on each one. So we've got an x plus 3, a single x plus 3 in the first denominator, and we have x plus 3 squared. We've got 2 of those in the second denominator. This is like x plus 3 to the first power here. So the exponent that's larger between a 1 and a 2 is a 2. So for the least common denominator, we're going to need x plus 3 squared. You go with the higher exponent whenever you have the same factor in both denominators. Okay, so x plus 3 squared. This first denominator has an x plus 5. This other denominator does not have an x plus 5. So this is like x plus 5 to the first power there. We just need a single x plus 5 for the common denominator. So our LCD, our least common denominator, is x plus 3 squared times x plus 5. I've got another example I'll show you momentarily. Okay, in this example we're asked to find the least common denominator of 4 over 2x plus 1 and negative 3 over x minus 6. So the first thing to do when asked to find the least common denominator is, if necessary, factor all of the denominators. I'm looking at both of these denominators and neither one can be factored. So we can skip that step. There's no factoring required. So in other words, the least common denominator, we can go right to it, is you look at the two denominators and think, what factors occur there? We have a 2x plus 1 in the first denominator. That factor does not occur in the second denominator, so we just use 2x plus 1 once. And we have an x minus 6 factor in the second denominator that we also need for the least common denominator. That factor does not occur in the first denominator, so we just need it once. There it is. I have one more common denominator example that we'll do together. In this example, we're asked to find the least common denominator of 1 over 6x squared and 7 over 8x squared plus 16x. So we first need to factor the second denominator. I noticed that we can factor the second denominator here. So we've got 1 over 6x squared and, let's see, 7 over, the common factor between these two terms appears to be 8x. So I'm going to factor out an 8x from both terms in the second denominator. That'll leave us with an x plus 2. Okay. So the very first step when trying to determine the least common denominator is to factor all denominators completely if necessary, and I believe that I've just done that. So comparing the two denominators, we're thinking about what the least common multiple of the two denominators is. Between a 6 and an 8, the least common multiple of those two numbers is 24. If you can just see that in your mind and just go with 24, then that's ideal. If you have trouble seeing that, what we can do is we could factor 6 and factor 8 like this. We could factor 6 as 2 times 3. This step is not necessary if you just realize that the least common multiple of 6 and 8 is 24. But we could factor 6 as 2 times 3. So we have 1 over 2 times 3 times x squared for the first fraction. And then for the second fraction, we could factor 8. 8 is actually 2 times 2 times 2, or 2 to the third power. So 2 cubed is 8 there, times x plus 2. Again, this step is not necessary if you just realize that it's 24. So the least common denominator is always the product of prime denominator factors, with each factor raised to the highest exponent it has in any denominator. So looking at our two denominators here, our least common denominator will need to have in it 2 to the third power, because this is 2 to the first power in the first denominator. 3 is a higher exponent than 1, so we need 2 cubed in the least common denominator. We've got a factor of 3 in the first denominator. We don't have any factors of 3 in the second denominator, so we just need one factor of 3 in the LCD. We've got an x squared factor in the first denominator and an x, which is like x to the first power, factor in the second denominator. 2 is a higher exponent than 1, so we need to go with x squared for the LCD. And we also have a factor here of x plus 2 in the second denominator. There is no factor of x plus 2 in the first denominator, so we just need a single x plus 2 factor for the LCD. So we got 2 cubed times 3 times x squared times x plus 2, which simplifies to 2 cubed is 8, 8 times 3 is 24. So 24 x squared times x plus 2. That's the least common denominator of those two expressions.